finding the area of a parallelogram to derive a formula for finding the area of a triangle. Why are we doing that? So that you can investigate finding the area of triangles. And today you'll know you've got it when you can successfully find the approximate area of a triangle using your measurements and the formula that you've derived for the area of a triangle. So what I would like you to do to get started is you're going to need a couple things for today's lesson. We discussed that today when I gave you a few extra things. Even though I told you weren't going to have to do your homework pages, you did have some pages that needed to come home today in order for you to be successful for today's math message. So as always, we're going to work through today's math message. You're going to need journal page 227, and you're also going to need that Math Master sheet that I gave to you, 212. And I'm going to pop back in to show you. It looks like this. It's the one with all the triangles that you're going to have to cut out and sort. So you're also going to need, obviously, scissors to cut those out and some tape. So I'm going to give you some time before we get going with the math message to cut out those 12 triangles. And when you come back, we're going to sort them in a certain way. So good time to hit pause, cut them out, and come on back. All right, so if you're back with me now, we're going to look at today's math message. That is on page 227 of your journal. And you also have the triangles that you cut out from Math Masters 212. So that was your first direction, cut apart one set of triangles from Math Masters page 212. Excuse me. B, circle how you will sort the triangles. So you have some options here. Do you want to sort them by side length, or do you want to sort them by angle measure? Doesn't matter which one you choose. Maybe you feel that you're stronger with one type of classification than the other. It's up to you. C says then you're going to sort the triangle cards into 3 piles according to your chosen attribute, sides or angles. So if you choose to sort them by sides, you're going to look for maybe 3 ways that you could pile those triangles together. What is something that you notice that some triangles have in common, and you're looking for 3 different piles there. D then says for each group, list the triangle that belongs in the group and briefly describe the rule for the group. So why did you decide to put your first pile of triangles together? And then you're going to tell me which triangles you grouped. Same thing for your second pile of triangles, and then tell me which triangles you grouped together. And for group 3, again, give me the rule. Why did you choose to put those triangles together? And then which triangles are grouped. Again, good time to hit pause, making those 3 piles of triangles according to the attributes that you've noticed. And when we come back, we'll go over the solutions. Okay, so if you are back with me, I'm going to first talk about those of you that decided to sort the triangles by sides. So in front of you, and I'm actually going to go to the presentation view so we can see the letters a little bit better here. So there were 3 different ways that you could have sorted those triangles by sides. And we're going to go into some definitions for these 3 side attributes in a minute. But first you'll notice the first group was equilateral. So here we have all 3 of our sides are the same length. And the 2 triangles that fell into that category were triangle D and triangle F. You'll notice they're the same shape but a different size. For the isosceles triangle, these triangles have 2 sides that are the same length. Now this wasn't actually proven in these pictures of triangles, but it appeared that we had 2 sides that were the same length. And those triangles, still a little blurry, but I'll do my best, B, E, I, J, and L. The third pile of triangles that you could have put together were triangles that we would identify as scalene triangles when we're talking about sides. In these triangles, you notice that the sides don't seem to have any common measurements. So all 3 sides are different lengths. And those triangles that fell into that category were triangle A, C, G, H, and K. So these are the 3 definitions for the types of triangles, those 3 different piles that you should have created. So we call equilateral triangles, that's when I have 3 sides of equal length. An isosceles triangle is when I have at least 2 sides of equal length. And some of you might say, wait, at least two sides? So could an equilateral triangle also be identified as isosceles? Absolutely. The definition says at least two sides. So if you have a triangle that also has an equilateral classification, it would fall into the category of isosceles as well. A scalene triangle has no sides of equal length, and that was that third group that we had seen there. Those of you that chose to group your triangles by angles, okay, these are the interior measures of the vertices of our triangle. We have our first category, which are right. So we have at least one right angle in there, and that's marked by this square in the corner that you see here, and the vertices that you see here. This angle is 90 degrees, and we identify those angles by drawing that square at the bottom. Yesterday we talked about this being perpendicular. So this would be easy for us to identify the height of this triangle because it has a perpendicular length from the base to the top, to the highest point of this triangle, or to the opposite side. So this would be the height of our triangle because we have that 90-degree angle. We also have a category of obtuse triangles. All right, this is where we have at least one obtuse angle within these triangles. And we also have the category of acute. Okay, our acute angles is where all three measurements inside of our triangle are acute measurements. So each angle is less than 90 degrees. And those triangles there would have been B, C, D, F, I, and J. Okay, so those are some of the solutions. Well, those are the solutions that you should have come up with when you were classifying those three groups, either by angle or by side length. Now I'd like you to take a look at page 227, which was your math message, but we're going to look at the bottom, number 2. And we're going to go back to the directions for that. So I'm going to exit our preview here, and we're going to go back to the ConnectEd presentation. And we're going to look at the exploring triangle areas. So what they're asking you to do here, again, this was another page that I was sure that you had in your possession for the evening, so I'm going to pop on. Okay, so this page looked like this. Okay, it's page 213, and we have those 3 sets of triangles that we needed to cut out. You'll notice that it's the same triangle, just a different corner is matched up with that shading. So, and you have those triangles marked A, B, C, D, and E, and F. So what I would like you to do for this, and let's actually look at the directions on this page. Okay, it says cut out triangles A and B from Math Masters page 213. So we're going to start with just A and B, and we'll come back to C, D, E, and F in a little bit. It says do not cut out the triangle below. So they don't want you to cut out the triangle that's actually in the journal page. They want you to cut out the ones on page 213. What they would like you to do from there is to tape triangles A and B together to form a parallelogram. And you'll notice on page 213 it goes into a little bit more of a description of what they would like you to do for that. They want you to tape the parallelogram together at the shaded corners, okay, or tape the triangles together at that shaded corner to form a parallelogram. Okay, so we would like you to take care of that right now. Cut out triangle A and B. Again, a good time to pause. And then right here in this space, you're going to tape that parallelogram, making sure that those side angles are touching. Okay, tape those triangles to form a parallelogram and be sure that those shaded angles are touching. So I'm actually going to go back to the Google Slides presentation. Again, good time to pause, take care of what you need to take care of, and come back. Okay, so if you're back with me, this is what your parallelogram should have looked like if you had taped them together in your journal there. What they're asking you to do on that page, okay, is to then identify the base. How long is the base? How high is the height? Remember, the height we define as a perpendicular line from the base to the top or to the opposite side in our parallelogram. And then they want to know the area of that triangle. Okay, but then you're doing the same thing over with the parallelogram. So let me go back to the ConnectEd presentation. Okay, so from here, it says the base of our triangle, and we can simply count 1, 2, 3, 4, 5, 6. So you should identify your base as 6. And you'll notice up here we're working with centimeters. So our base is 6 centimeters. Make sure you always have the units on your number answers. Our height, again, our height is that perpendicular line that goes from our base to our opposite side. So for this circumstance, we're going to go from this base up to this angle at the top. And you'll notice we can count that as 1, 2, 3, 4 centimeters. Okay, so when I'm finding the area of a triangle, I'm going to tell you that this should be 12 centimeters squared. 12 centimeters squared. Now you were probably able to count that by counting the full square centimeters that you have here and then matching up. Obviously this would match up here, this piece would match up here, so you're able to come up with 12 centimeters squared. Here you have your taped parallelogram where we've combined triangle A and triangle B, and we now have that parallelogram that you see here on the Google Slides presentation. So here, reflecting on what we did yesterday, to find the area of our parallelogram, we don't need to actually count spaces. We know that the formula is the base times the height. So here we can count our base is 1, 2, 3, 4, 5, 6 centimeters. Our height, again, moving from the base, we're looking for that perpendicular line that's touching the opposite side. We have a height of 1, 2, 3, 4 centimeters. So again, I do 6 times 4 to get that 24 centimeters squared for the area of my parallelogram. And you can go over to your journal on page 227 and fill that in. So for the base, we have, and hey, let's do it together. We have 6 centimeters. For our height, we had that 4 centimeters. And for the area of our parallelogram, we came up with, it's not going to cooperate with me here. Let me get rid of that. There we go. We have that 24. Doesn't want to play nice. Maybe we'll type. So we have that 24 centimeters squared centimeters. Okay. Over here, we had for our base, we had 6 centimeters. For our height, we had 4 centimeters. But when I found the area of my triangle, I got for some reason it doesn't want to write that low. We'll just hit enter and we'll put 24 squared centimeters. Of course it's hidden. Maybe because it's not right. It doesn't like me. Okay, so for our area for a triangle, it should be 12 squared centimeters. Nope, not working. Okay, so what I want you to notice, and maybe I'll just go up here and write this a little higher so you can see it. So we have our 12 centimeters squared. But the area of our parallelogram, where we connected those two triangles, our area was 24 squared centimeters, or centimeters squared. So what I want you to notice is the relationship. What do you notice about the relationship between the base and the height, even though that I doubled my triangles and put them next door to each other to make that parallelogram? So the base and my height are the same, but look at the relationship between your area of your triangle and your area of your parallelogram. This is going to be important when you're discovering your formula for how to find the area of that triangle. So again, this is what your parallelogram should look like when you combine those two triangles. Notice that they're the same triangle, they just have a different corner that's shaded in. Here we have the same triangle, the same triangle. So the area of that parallelogram is going to be double the area of one single triangle. So I want you to keep that in mind when you're working through today's lesson and you're discovering how to find the area of that triangle, using what you know about